Yeah, this is the last panel of the day. There were so many, and I'm really happy to be here with two friends, two colleagues, and yeah, open source contributors. Yeah, I'm Dana Todea, DevRel engineer at Victoria Metrics, part of the Open Telemetry community, Cloud Native Days Romania organizer, and neurodiversity merge forward lead, right? Josh?
Yeah, hey, my name is Josh. I am a developer advocate at Altinity. We do ClickHouse stuff, which if you don't want to talk to me about that, I'd love to talk about that. But I am obsessed with observability. I'm our Open Telemetry SME. I'm also a co-organizer for the open source analytics community, which sometimes hosts events in New York, and we'll be hosting our first in-person conference in San Francisco in November.
Yeah. Hi, everyone. My name is Valencia. Happy to be here with you. I am curious to know that maybe will be the new skills that I got it and have a little proud, and anyone that need help, just ping me. Also, operational resilience intact that I would like to explain better, that everyone want to start to contribute or understand better the initiatives. I'm also very proud that CNCF ambassador together with many others that we are trying to help the open source CNCF projects.
Excellent. So there you go. We will talk about telemetry that matters. Can you hear me fine? Because I think it's going on and off. Right. So yeah. So the problem statement is that we are collecting so much telemetry, so much data, but are we gaining any real insight, or yeah, we're just, we're doing it for the sake of adding more data. What do you think, Josh?
I think that we should just pay to store stuff on hard drives and never use it. That makes sense.
Makes sense, yeah, totally. Yeah, well, basically, yeah, we are just gathering so much data, and to be honest, 90% of the data is never acted upon. 50% of the metrics, we never do anything with it, so yeah, that's gonna be waste. We are wasting a lot of engineering effort, creating alerting noise, creating cognitive load. So really a bunch of things that, for us, developers, managers, whatever, it's not really that great. We should focus more on green observability, sustainability, actually reducing this toil, reducing the telemetry, and think about, act upon it like being an optimization.
Yeah. I know one company that I'm not sure if I can name, so I won't, but they're collecting and processing 1,000 petabytes per day just of telemetry. So an entire exabyte per day through their systems.
That's huge. Yeah. That's so definitely we don't want that. Definitely we have to think about other techniques, how we can optimize this. So being part of the observability for such a long time, we definitely start to think and plan and design things from day zero, right? So what good looks like, what telemetry should look like, what signals we need to export, and definitely the goal here is not to collect more, but collect what matters, right?
Yeah.
So this is like the problem statement for this panel, and we'll start with.
Yeah, so if you're collecting an exabyte per day, you can get a lot of gains, like a 0.01% gain in your processing can save you a lot of money. But for the rest of us who live on planet Earth, we can't just like add efficiency to the pipeline and save money that way. We have to be more intentional. We have to start from the beginning. Yeah. So, Dana, Carol, what do we actually need? What telemetry do we actually need when it's time to resolve an incident?
Right, so basically, I know we've been working in observability for quite some time, but not all of you work in observability, so probably you don't know what we are talking about. So we need to start from the basics with the observability signals, like the log, traces, and metrics. And especially we are talking about open telemetry, they use a fourth signal, which is called profiles. So for example, traces are really important because they track the journey of a request across services and dependencies. The metrics will measure system behavior over time, like request rates, CPU usage, latency distributions. And the logs are really important because they are time-stamped, they capture events. So all of these are really, really important for us, right? And they also give us contextual information, right? Everything matters if we are putting it and we are, how can I say, interpret it with our business logic, right? If we don't interpret it with our own business logic or it doesn't make sense, it's not correlated, then basically we are not collecting the right data. The profiles will keep divisibility into the resource usage, like CPU, the memory, execution hotspots over time. So basically, we need to think about observability through like modern age. Like many people have been saying, like from the beginning of observability as a, let's say, term, that is very silos, all the signals are isolated, they don't communicate, but that's not true, right? Observability is actually a mesh, a network. So we see all these signals that are actually interconnected and they give us information about all these tools and the services, right? So definitely we need to think about observability as a dynamic ecosystem where we could actually correlate all the signals together. And I think you had some follow-up.
Yeah, how can we actually do that in practice? That sounds great.
Yeah, we have many problems, like, for example, cloud-native personas. That is an initiative that we are tracking inside of the CNCF initiatives. Like, we have different roles, profiles. We have a developer that maybe need more cardinality to add in the tracings. But also we have the operator cluster that they will need to use more metrics. The initiative is to track these persons to help to improve how to use better observability toolings and try to be more efficiently and avoid alert fatigue and this kind of thing. So this is an initiative inside of the operational resilience. So everyone that want to contribute and give this insight is very valuable to try to build this this matrix of personas across the observabilities, monitors, metrics, traces, and elements.
Yeah, no, that's really nice. I didn't even know about it, so thank you, Carol, for bringing it up. But yeah, will be like the next question, like how do we correlate this telemetry?
Oh, I love this question. This is one of my favorite topics. So we talked, like Diana talked to us about the signals, right? Profiles, metrics, and logs, and traces. How can I forget traces, the most important one? Those are cool, but they all have this one thing in common that I think we forget about often. It's that resource metadata. And we're like, oh yeah, that's just like the tags and the labels that we throw on that. Well, those tags and labels represent the things that we actually care about. I, as an engineer, do not care about logs. I do not care about metrics. I don't care about traces. I care about the process that isn't working. I care about the pod that crashed. I care about the node that's down. These things are described in the resource metadata, and they have real-world relationships to each other. So we're not just doing one-to-one matching, right? But we need some things that don't quite exist yet in the OpenTelemetry project, but maybe your vendor can provide them or you can build them yourselves. We need graphs and topologies, right? We need to understand the service topology. This certainly exists in distributed tracing tools, but also the dependency topology, right? What is running where, on what, connected to what. And once we have those topologies, it actually becomes really, really easy to answer this question of correlating data, correlating the telemetry, and we can kind of navigate around based on these entities that we care about, like pods and processes and services, and see all of the relevant telemetry, no matter what database it's coming from.
Nice, yeah. So we are seeing right now how to correlate the telemetry, but you know we are talking also about instrumentation. Like obviously, if you are like in engineering or you have done something with OpenTelemetry, you'll know that we have zero code and manual code. So yeah, manual instrumentation. And we're like want to talk right now about the benefits and limitations. And yeah, Josh can start with.
Yeah, so we're here to talk about telemetry that matters, and there's actually three kinds, right? There's, depending on where you look in the timeline of how these things were described, right? There's auto instrumentation, which is a broader term that was too broad and meant too many things to too many different people. So now we've got instrumentation libraries, which are great, and zero code instrumentation. Zero code instrumentation is a way to inject those instrumentation libraries into your projects after they've been deployed or built. It also contains additional instrumentation that can't be done at the code level, but is done at the runtime level by things like the Java agent or the .NET agent. So zero code instrumentation is really, really powerful, and in some cases it can be the only way to get the information that you need, especially if you're trying to instrument code that was written by another team or another company, right, and you don't have the ability to modify it and rebuild it. It's also really, really great if you're working in a homogeneous environment, right? If you're working entirely in Java or entirely in .NET, auto instrumentation is going to be consistent and look really great for you. It can create a lot of noise, and it can also create a lot of inconsistent telemetry because the SDKs for the auto instrumentation evolve at different rates and update as the semantic conventions update on their own life cycles as the maintainers get around to it. So you end up with different versions of the semantic conventions coming in from your various SDKs.
Right, and then you have the manual instrumentation because like some teams, let's say they want to keep on top of their code and they want to be very precise and they want to control everything. So that's also really, really cool because they want to have something very specific, not just generic defaults there that come from the normal configuration. They want to make it applied to their own business logic in their company. So what we see here is that obviously there's with manual instrumentation, it's good because you could have a lot of precision, but then the downside is that you require a lot of maintenance. So you need to be very disciplined as an engineer to actually keep on track to whatever happened with your instrumentation. You need to, in the long term, you need to maintain that code base. And if you have different teams, it's also kind of hard to scale, right? But then again, the benefit will be that you have consistency across the signals. And if you're doing it well, you can design it with the traces, logs, and metrics together. And you have a coherent story of whatever is flowing throughout your system. So that's the good part with manual instrumentation. But like Josh said, we have like how many SDKs in OpenTelemetry? There are so many things. So you will end up, if you're not doing things correctly, you'll end up with uneven instrumentation. And then probably you'll have lots of environments that is kind of difficult to manage. And also, if you're not doing very well, you can have like a lot of noise. Or you're going to collect low-key, let's say, low-value telemetry. So manual instrumentation is pretty cool, but you need to do it correctly and requires discipline, consistency, and also careful design.
And competency, right? Like this intentional instrumentation path is great if you work with really good engineers. Not all of us are lucky enough to only work with really good engineers.
Yep, that's true. So we're coming to day 2, yay! So once you have all these pieces, how do you optimize? So we have some reduction strategies, I think.
Yeah, day 0 is a happy day. We are installing our components. Everything is working. Day 1, we are getting the telemetry, and day 2, we are getting a lot of problems because scaling and getting all the telemetry in production could be very tricky, like alert fatigue, cost, and many other problems. So we would like to create some white papers reference with your help how you are really doing successful in day 2 inside of your cross organizations. For example, green observability is a hot topic and it's really hard to define how to get it, like using with projects like Kepler and other initiatives, and we are really want to focus in green observability and how to improve cost, carbon, and these kind of topics. And all of this, you are welcome, please, to, with your vision in your industry work, try to build together this best practice, so maybe white papers to how work together this best practice.
Yeah, and we definitely need that in the community. We definitely need the end user stories. That's very, very important because we can always find out whatever techniques the end users are actually applying in their production environments. But to come back to the reduction strategies, like for example, sampling and cardinality management can be like very important techniques here. Like they act like main pressure valves when we have observability at scale. So basically, what will keep systems usable instead of drowning in your own data. So sampling is about reducing the volume here, and instead of keeping every single trace or log, then we need to keep a representative subset. For example, you might want to keep like all failed or slow requests. Don't do that. Just keep like between 1% and 5% of successful ones. And cardinality, on the other hand, is something about reducing dimensional explosion. And this is actually pertains more to metrics if you're working with metrics. So if you're going to add like high cardinality labels like user ID, request ID, session ID, then pretty much you're going to explode your metrics there in when you work in time series with time series database, for example. So you want to be careful with that. So just don't track everything. Just focus on the important signals, the repetitive ones, right? And the goal is to reduce the cost, like we were discussing so far, and that's very good. We talked about over-instrumenting, right? So it's very easy to fall on the other side where you over-instrument, thinking that, yeah, it's very important to keep track of everything. And as you've seen, like even good engineers sometimes can actually fall into over-instrumenting. But anyway, so the semantic conventions is something that also the OpenTelemetry is working on. It's a very good project at the moment, and something that right now it's also a hot topic. So why is it important? Because we can have consistent service name, operation names with it, status codes across the signals. What we do, we enrich once and not everywhere. Maybe like an example would be like adding Kubernetes or infra metadata in the pipeline instead of per service instrumentation. But we are reaching this very hot topic. Everybody loves AI, right? So what about agentic flows? How are we monitoring with OpenTelemetry? Do you guys have any use cases?
Yeah. This is actually, if you were at the OpenTelemetry roundtable this morning, and you heard me talk about how this is actually the only thing my company is currently using OpenTelemetry for. Couldn't get it in there for the observability, but for those agentic workflows, it's pretty cool. What's awesome is that a lot of these LLM-based tools, right, they've come out in the last year or two. OpenTelemetry has also matured and reached graduation status within the last year, and so there's a lot of support for OpenTelemetry within all of these LLM tools that you're probably using. Every single coding harness that I have used, like especially the official ones, supports OpenTelemetry out of the box. All you have to do is define your environment variables of where to actually send that OTLP, and it'll start getting sent. That's really, really cool. And then we also have this, right, like once that if you're not just going to like one of the frontier models from one of the providers, if you're going to something running locally or in like K-agent or something, or you have multiple steps, distributed tracing is going to become your friend if you're not already using it. It's going to let you have the kind of cardinality that you need to actually understand what's going on. It is going to get a little bit tricky with the way that some of these workflows work because they're going to be more asynchronous and long-lived, and that can be challenging for tracing, right? Like defining when the actual trace ends is a tricky challenge. So I would recommend that if you're trying to observe all of this and you have more complex workflows, look into things like span links rather than just trying to make one continuous trace.
Yep, that's really, really awesome. And right now is like, okay, we've been talking about so many techniques, and yeah, because we are at the KCD event, it's always good to know like what the community is doing at the moment, and our audience can learn more about that. We have the reference.
Okay.
Yeah.
Yeah, just talking a little more, explaining some initiatives that I was sharing, like observability persons or green observability. All of these white papers or reference best practice, you can participate going to the TAC operational resilience. Maybe many people don't know what means TAC. That will be technical advisor groups that is inside of the CNCF. So the really is that we need people that like you, that you are here, that contribute with your experience and sharing what you are doing currently in your industry, in your job, and help us with your insights to create this reference. For example, we have already these initiatives that is reference framework for level service reliability automatations that is how will be the new defined parameters that will be automatations when we are talking about in observability agents. And we have, generally this initiative will have weekly meetings by Zoom that you can start discuss and started to create these documents, reference documents or white paper that maybe you already see it in the CNCF, these white papers. That is the way that we working together with people like you to create these documents with your participation. So it's, this is some samples, but it could be any other topic that really we need to discuss. Right now, Severin started reference framework. We have another for observability personas that is something that we track that we need to match better the persons and the toolings to use better the telemetry that we are using. Yeah? Green observability is not currently initiative, but I think we will push it because it's a hot topic that many projects like Kepler and other open source projects, we would like to have some reference guide how to use these reference initiatives, open source projects inside. And you are welcome, just join to the CNCF Slack and you will see all the tags. We have like 5 tags. Maybe you are more related to security or workloads, but just join to the tags and you can be involved and say, oh, I would like to participate in this, and we try to help you to navigate in this. Yeah.
Yeah, and that's actually like very good initiatives and something that, it's well applauded. I would also like, maybe from my point of view, to add another takeaway. Don't rest till you find something that works for you, like a technique that works for you, because let's say every company has a different use case. Right now, for example, the community is working on retroactive sampling, something that has been discussed even at KubeCon Amsterdam this year. Just to give a very brief summary, it's about you don't need to decide up front what to fully ingest. You can just collect a lightweight representation of traces, make the sampling decision centrally, and then pull back the full trace data for the selected sample. So anyway, it's a technique, it's a powerful technique that other companies have been working on, and from our side, we are working at it, and we are happily, we want to donate it to Open Telemetry community once we are fine-tuning it. So that's also something that we want to collaborate with the community here. And
that'd be awesome.
Yeah.
Yeah. And the last thing I'll just add to that is, we've talked about some kind of aspirational things, like Kepler is really cool. This sounds really cool once it's ready.
Yeah.
In the meantime, you can't optimize what you can't measure. The OpenTelemetry collector is great at measuring what we're ingesting. It has all of those metrics that we can keep track of, so we know what we actually ingested. But you should also be measuring what you're storing and what you're using, and how often you're using the telemetry that you have stored, and tracking your outcomes as well.
Excellent. And with that, we are open for questions. I think we have a lot of time. We can talk about either the topics that you've seen or anything you're related to cloud native, open source. The floor is yours.
That you share about the tag program, is there a specific Slack channel or link that we should go to join it? Or?
Yeah, the name is just Operational Resilience. You start with tag in the channel, you will see it to join it.
Okay.
Just put the word tag in the search channels in the Slack of the CNCF, and you will see it, tag Operational Resilience.
Okay.
And the others, it's 5 tags in totally, and you can join. It's very nice that you can see the other initiatives, that the other tags, that is security, workloads, developer experience, that you can participate and see, because each tag has more initiatives. That will be very nice also. Yeah, you can be more.
Okay, good to know.
Hello. Whoa. Okay. Is there any metric or data that you found surprisingly useful to collect, like something you didn't expect to be, but then you've found that it comes in handy to have during incidents and such?
Generally, surprising, no, I can't think of any surprising examples. Can you? I would say it's better to monitor symptoms than causes, which might be surprising to some people, because it's very, very easy to monitor causes, right? Things like, is the hard disk full, how much memory is being used, the CPU utilization. And it's good to know those things and have them for when you're actually trying to do your root cause analysis. But for simply understanding, is there a problem that I need to spend more time working on? You should be monitoring your user outcomes and user experiences.
Thank you.
Any more questions, guys? So I would like to know, have you seen use cases where people are consuming OTel data in agentic workloads rather than it being driving said agentic workloads?
Yeah. Yes. Yeah. Sorry. As sort of the first step, right? I haven't seen any successful fully automated agentic remediation. But as a first step, as sort of a tool to find that needle in the haystack that you can then go and verify, yes, it's extremely useful. There's the OTel MCP. This is like, I don't do this at scale, but just like messing around on my home lab, I have an OTel collector and ClickHouse and an MCP server, and that's the whole stack. Oh, and Grafana, of course.
I mean, specifically with the context limitations that we have today, if you were to flow the entire OTel time series data, your agentic workflow would die.
Yeah, no, not for the, I wouldn't send like exactly the actual raw signals, but when you're like looking at the metadata, even checking logs, right? And there's even some arguments, right, where like you don't need to be collecting everything now because the agents, if they have access, can go get the ground truth from the actual services themselves. Which is cool, but yes, definitely you want to be controlling that context carefully, not shoving, a million tokens into the window and making your...
And I assume there is a lot of metadata aspects to this, because if you don't label your data correctly, then your agents don't know what to look for.
Sure, and it can even be useful, right, like for examining a section of a time series, once you found the right time series or the right time period.
Thank you.
So I don't know if this question's going to come off as uninformed, but do you have experience? I know there are some packages that use, I think it's called eBPF, for like syscall tracing. Do you have experience with those, and was it positive, negative?
Yeah, I think we kind of glossed over that a little too much during our auto instrumentation part. Yeah. But that's the other, so besides the types of auto instrumentation that I mentioned, there's eBPF-based auto instrumentation, which is happening, as you mentioned, at the kernel level, at the syscall level. This is really, really powerful because it lets us see every single network call, and we know that we're not missing anything. So hey, is my telemetry good? And I'm trying to evaluate the quality of my telemetry. Having eBPF as another source is really, really valuable. If you're just trying to understand, like, okay, what services talk to what other services and really quickly get your entire network topology, eBPF is like an awesome way to do that because you don't even need to modify a single artifact. You just deploy an agent on every node and boom, you know what's talking to what. That being said, it can be overly verbose. I have some strong opinions about how maintainable these things are because they're so deeply integrated into like the implementation details of what's happening inside Linux. It also only works in Linux. And then OBI is a project that I wish I knew more about, but I would recommend that you check out OBI. And I believe that came from Grafana Bela, but it is now a CNCF project.
Yeah, so eBPF, OBI is the same thing, right? So before it was called eBPF, now it's called OBI. But yeah, it's a donation from Grafana Bela. Yep. But yeah, to answer concretely, it depends on the end user cases. So yeah, let's say the same. Also, like OBI instrumentation is available via the CNCF Slack channel. So if you have like specific questions, it's better to just ask there, as they have like the maintainers and also the end users get together, and you'll have like more complete feedback, or anyway something that's more concrete in that sense.
I have a question actually. I was looking at videos of Observability Summit, and I saw a project called AK Query. Have you guys heard of it?
AK Query?
Yeah, it was by a Stanford PhD student. So these guys are building it out. It kind of, I mean, it's a drop-in replacement. I mean, you don't need to sample. You store it and retrieve it more efficiently. So do you see any sort of use case for?
That sounds great. I don't know anything about it, but that sounds really cool because sampling is fraught.
Okay, yeah, I'll have to check that one. I mean, I was there, I gave the same talk there, but yeah, I have to check like all the videos.
Got it. Yeah, because I think they use hash maps to retrieve it more efficiently. So.
Cool.
Okay, yeah, that's good to know. Thank you.
Any other questions? I guess that's it then.
Thanks. See you all at the happy hour.
Thank you so much. Thank you.